Hey guys. Okay, so we're doing a second sheet for section 2.1, and this is over linear equations in one variable. Okay, let's look at the first problem. It says, how do you determine if a value for a variable is a solution to the equation? And I think you probably all know that answer, but the answer is that you plug it into the original equation. Okay, so just plug it. Original equation, and then if it results in a true statement, it's a solution. That little arrow means implies solution. Okay. Alright, so number 2. The goal in solving any linear equation is to get the variable by itself with the coefficient of 1. That is, to isolate the variable. List 5 steps you must use when solving a linear equation in one variable. So my first one that I listed would be to remove the grouping symbols. So this would be the parentheses, right? And you do that by distribution or distributing. I'm just going to put distribute. The second thing that I think you should do, is that you should combine like terms. Next would be to get the variables on one side and the constants on the other. So remember, constants are just any number that doesn't have a variable attached to it. Okay. Now next is to solve, right? You just solve for your variable. So you're either your x or whatever your variable is. Sometimes they switch it up. Not often, though. And then last but not least, we always check your solution, right? Your proposed solution, and make sure that it is true. Okay, now we're going to solve this linear equation. And you can notice that it's rational, right? It's a fraction, so the first thing that we need to do is find our least common denominator. And to do that, we are going to write each denominator in prime factored form. So we're going to have 12, 4, and 2. Well, try 12 in prime factored form. Well, we know it's 4 times 3, right? But 4 is 2 times 2 times 3. Well, 4 in prime factored form is just 2 times 2, and 2 is 1 times 2, right? Because 2 is the even prime. Alright, so let's see what they have in common. Oh, I do. I thought I got this one, sorry. Is 2. So, we're going to bring that down here. So, least common denominator, well, that's going to start with that 2. And then what we have outside is going to be a 2 and a 3. So times 2 times 3, that makes our least common denominator equal 12. We could have wrote the 1 down there too, but I mean, it's kind of silly because anything times 1 is just itself. So now it wants us to use the multiplication property of equality, which means we're going to multiply both sides by 12. It says to use the distribution property, which means we're just going to have 12, if I can write it, 12 times 2x plus 3 over 2 minus 12 times x minus 1 over 4 equals x plus 5 over 12 times 12. Okay, now let's start our cancellations. So 2 goes into 12 6 times. 4 goes into 12 3 times. And 12 goes into 12 1 time. Okay, so since we've divided all those out, we could write this like 6 times 2x plus 3 minus 3 times x minus 1 quantity, and then x plus 5. Well, that's just times 1, so I'm not even going to mess with that once again. Now, we're going to have to get rid of the grouping symbols, right? That's the first thing that we said we were going to try to do, so different color, this guy. So to do that, we would take the 6 in and the 3 in, right, into our grouping symbols, which are our parentheses, and that is called distribution. So we would use distribution, which would result in 12x plus 18 minus 3x minus 3, which would equal x plus 5. Okay? So now we're going to combine like terms. So let's go maybe to the light green. So we're going to have the 12x and the negative 3 on this side. So that's going to give us 9x. And then if we have the 18 and the 3, it's going to be plus 21. That's going to equal x plus 5. Okay. Now, we want to get, remember, well, shouldn't have scrolled yet. We want to get the variables on one side and the constants on the other. When possible, try to get your x's on the left-hand side and your constants on the right-hand side. Yeah, I know you're probably thinking like, well, what does it matter, Miss Owens? It's going to matter later on when we get into inequalities, so it's just a good habit to get into now, okay? Like, form good habits early, and then you'll have them when we get to inequalities. Sometimes it's just, if you do it, it's going to be a negative, and it's just easier to do to the right, so do that if you have to, but try to do it to the left. So, here, let's subtract, pins doing crazy things. Let's subtract x on both sides, okay? So that's going to give us an 8x plus 21 equals 5, okay? Now, remember, now we have all of our x's over on this side, but now we want our constants on the other. So let's subtract 21 from each side, okay? So that is going to give us 8x minus 16. Okay? Now, we divide both sides by 8. I'm just going to go ahead and do that on both sides. I forgot my, sorry, I was in a hurry, getting excited about math, and there you go. Now divide by, so equal, and then a negative, sorry. Kind of wrote it in shorthand just this morning. So this is going to be 2x. No, it's not, it's just going to be x. 2's on the other side. X equals negative 2. There, that's what I meant to write. Okay. So now we're going to substitute our value in and make sure it's correct. Okay. So I'm going to have to write kind of little. Let's pick a different color. So if we have 2 times the negative 2 plus 3 all over 2 minus negative 2 minus 1 over 4, that should equal negative 2 plus 5 over 12. Now, if we simplify this, I think I could go this way and make it fit, maybe. So that's going to be negative 4 plus 3, so it would be negative 1 over 2, right? And then negative times a negative, it's going to be positive in a minute, but this is going to be a negative 3. Didn't mean to write on that, so negative 3, positive 3, plus 3/4. And that should equal negative 2 and 5, 3 over 12. So I'm going to go back down here. We would have to make this be a 4 before we can join them, right? So that would be times 2. So we'd have to also multiply the top by 2. So that's going to be negative 2 over 4 plus 3 over 4. and that should equal 3 over 12 if we're right. Okay? Let's look. So this would equal this side. Let me go this way. This side equals 1/4. We agree? Now, if we simplify this, 3 goes into 3 one time, and 3 goes into 12 4 times. So that is a true statement. So -2 is good. So our solution set would be -2. Okay? Awesome. All right. So we're going to solve the linear equation and decide whether the equation is an identity, contradiction, or if it's conditional. Okay, so let's just distribute our -2 and our -6 in. So that's going to give us a -6x plus 2 equals 4 minus 6x minus 18. Let's go this way. -6x plus 2. That's going to equal -6x minus 14. Okay. Now we can switch colors. Blue. I like this blue. Okay, so let's add 6x to both sides. So both of these are going to cancel, and that's going to leave us with 2 equals -14. Is that a true statement or false statement? It's a false statement. So is the last statement of the solution true or false? So it's false. So if it's false, that means our solution set is the empty set. That's no. That's no good. And then this equation is a contradiction, right? Because it definitely contradicts itself, right? 2 is not -14. This is how you write contradiction, shorthand. Okay, let's do the next one. So on this one, we'll distribute the -5 and the -2, okay? So this is going to be 3 minus 10x minus 5 minus 9 equals -4x plus 5 minus 6x minus 16. So we just have 1, which is going to be negative. Let's change colors, please, Shirley. -10x, and then we could add, so it's going to be -11, and that's going to equal -10x and -11. So we could always do the same thing we did before, right? And add 10x to both sides, which will leave us with -11 equals -11. And that is true. So if that's a true statement, therefore the solution is all real numbers, or you could write it as x such that line means such that, remember, x is, I guess I should say any, not all, any real number. And since it's true, it's going to be identity. Okay? Alright. So that is my portion. That is the guided portion, and I'm going to leave you with the to-do math. Okay? Alright. You guys have the best day.